Hello guys, welcome to this tutorial series on EMV. My name is Derek Pingyu and I'm a hardware software engineer. Today we're going to be talking about EMV protocol and parameter selection. First, we're going to look at the usage, and then we're going to move on and see how the request and response structure look like. And then following that, we're going to check on a successful protocol and parameter selection exchange. And at the end, we gonna, of course, look at everything I talked about on a demo using a PSoC microcontroller from Cypress. The protocol and parameter selection is used by an interface device, for example, a terminal, to negotiate communication protocols, either T0 or T1, and also to negotiate parameters from an answer to result. If you don't know about answer to result, I did a video on that, just check it out. It's pretty simple. So the protocol and parameter selection is actually what is done after an answer to result from a card. So it's basically just to use to negotiate values that you receive from a card if they don't suit the values that you're using in your terminal or your interface device. So the next thing we're going to look at is how the request and response look like. Now, there is an initial byte, the PPSS byte, that is always coded as FF, this one. And the format byte follows the PPSS byte. The format byte kind of like codes in the first 4 bit, the first 4 least significant bits. It's used to code the protocol, either T0 or T1. So if it's 0, it's going to be T0, and if it's 1, it's going to be T1 protocol. Then the bits 5, 6, and 7 are used to code 3 bytes. These are the PPS1 byte, the PPS2, and the PPS3 byte respectively. Okay, and bit 8 of the PPS0 is reserved, and it's always set to 0. So now PPS 0 byte is used to code which other byte will be found in the structure. So these are the PPS1, the PPS2, and the PPS3. Like I said, it is used to negotiate values, and the values are coded in PPS1. These are the FI and the DI values, which are coded the same as in the TA1, as we saw in the other video in the answer to research. So this is a table I took from Wikipedia. And like I said, the idea in this selection negotiation is to excuse me, is to kind of like negotiate with a card that you want to use default values, or the values that you program in your interface device, and make sure the card accepts it. If the card doesn't accept it, further communication will not be allowed. So I chose to use the default value of 1 and 1. So my DI will be 1 and my FI will be 372. That will give me a baud rate of 9,600 bits per second. Okay, PS2 encodes the SPU and PS3 is reserved. So PS2 and PS3 are rarely used. And then at the end, there is a check byte, the PCK byte. It is the logical XOR of PPS1. It's supposed to be XOR, here is an error. Of PPSS right down to PPS3. So like I said, this is how the structure looks like, and the response also looks like this. So you have this format byte and then the initial byte that defines if these optional bytes exist, and then the PCK byte, which is just the checksum, and that is the exclusive OR of all the existing bytes. The rule for a successful PPS exchange is very simple. The PPS response just has to be similar to the PPS request. So if you send a series of bytes and then you receive the response and they're not the same, then just know the card didn't accept it. We just don't want to go into details to explain which bit has to be set and which bit does not have to be set, but just put it at the back of your mind that the card will always kind of like mirror your request if it's a successful exchange. And that's it. Okay, let's move over to the demo session, and I'm going to show you guys how I program the structure of the PPS and how I send and the response I receive, and then I'll show you what a successful response looks like and what a non-successful response also looks like. Okay, this is my PPS structure that I define. Like I said, we have the format byte, the initial byte, that encodes if these three optional bytes exist, and these are the optional bytes, and then at the end we have the check byte. And these are some masks that I just defined here, for PPS1, PPS1, PPS2, and PPS3. These are the masks that I'm gonna use in the code to check if they exist. So I'm gonna kind of like do an AND with this byte and check if these ones have to exist, and then I use them. Okay, so this is my function that I use to do the transaction. And yeah, what I do here is like I define my array. So I have 6 bytes here. So maximum bytes that I'm gonna receive are 12 bytes because the card will always send your request and then send your response again back. So I just define the maximum byte that I can always receive from the card, and then I use it to receive the response at some later point. And here I just initialize those variables to 0 with a memset. And then this is where I build my structure. I set the PPSS to FF as defined by the specification. And then I check here if my protocol is the T0 protocol, then I just define that I want to use only the PPS1 byte. And then I set my protocol here to the T0 protocol. Remember the 4 least significant bits are used to code the protocol. And then bit 4, bit 5, 6, and 7 are used to encode if PPS1 to PPS3 will be present. And here is when I have the protocol T1 and I set this value to 1. So as in any case, I always want to use the PPS1. So this is where I set my default value, and it's coded same as the TA1 in the answer to research. So it's just 1 1 to use 372 and D1 to be 1. Okay, now I start transmitting my bytes. I first send the format byte, and then here I send the initial byte. Now I check if I have the PS1 byte with this mask that I talked about before. Then I send the PS1 byte, same with the PS2 and PS3. And then here I calculate the checksum, and this is just the exclusive OR of all the bytes from PPSS to PPS3. And then here I send the checksum. Then I receive the answer from the card. And yeah, I haven't really implemented this part to check the response, but I'm gonna debug it and show you how the response looks like. But all the same, the response just have to be equal to the request. Yeah, I just said if it's 8, it's just some hard-coded stuff because I was really kind of like trying to get the results as fast as possible so I can make the video. Okay, let's go to the debug section. Now I'm gonna start my debug. And I'm just gonna let it run to this point where I've sent everything and I've received it, and then I'm gonna show you the local variables here for you to see exactly how they look like. Okay, now we are here. This is my PTS command. So I have the format byte, the initial byte to be 1 1 because my card uses the T1 protocol, and I use the PPS one to code 1 that is my frequency value or my baud rate value to be 9600 bits per second, and the PS2 and PS3 bytes, I don't use them. And I calculate my PCK byte to give me FF. So when I receive my bytes from my card, this is what it looks like. Okay, the length is I receive 8 bytes because I sent 4 bytes. Remember? So this is my request. The first 4 bytes are my request, and then the last 4 bytes are the response. So you see here that the response is just identical to the request. So if I try to let's try something. This is my card ATR, and in the TA1 we can see what my card requested. Now it requested 96 codes in the least significant bit 6, that is 32, and in the most significant bit it's 9. On the table it is 512. Okay, now I wanna propose a value that I know the card won't accept, because most cards will always accept the default value, which is what I use. And then if you propose something else which is not a default, it's highly probable that the card won't accept. So let's try, let me see, let's try 7, that will be DI is gonna be 64. Let's try, no, 8, DI will be 12, and then 6. So let's try something like 86 for PS1. 86 here. 86 is not the default value, and it's also not the value that my card sent during the answer to research. Let's see what happens. Let it run. Okay. Now, as you can see here, my PS1 value has changed, and my check byte also changed, and now the response is really interesting. Okay, you see that my card sends the request, but no response. So this is a case where the card says no, it's not gonna work. The card doesn't accept it. So that is just exactly how a non-successful communication, PPS communication looks like. Yeah. So it's all left to you on how you want to check which one is successful and which one is not successful. But the best way for you is to always check if it's identical to your request. Okay, that's it. Thank you guys. If there's any question, just let it on the comment section, and I'm gonna